Welcome back everyone to another exercise about system Verilog constraint, and in at this time we will write a constraint for a random variable, and it will be a two-dimensional array. So it will be a two-dimensional array, and it will have 8 rows and 8 columns. And each elements present inside the matrix will be of bit data type. So we have to randomize it in such a way that sum of each row will be either equal to 3 or 5. So this will just create a matrix, 8 by 8 matrix, and we will have 8 rows and 8 columns, and our constraint requires us to write it in such a way that sum of each of the row will be equals to 3 or 5. So let us begin. So first I will declare a class and I will call it cons1, and then I will put the rand keyword before the data type, and after this we will begin with our main constraint. I will call it main underscore c, and the very first thing we will be doing is to iterate through every row. So I will just use for each loop, and since we only want to iterate through the row, we will only be writing only one iteration variable, not something like this. So this should be enough, and right after this we have to write our constraint. So we can think of so many ways. For example, we could just write uh, a the first element, like we could just write a condition that if I is greater than 0, and then we will begin that the sum of the a I plus a I minus 1 plus a I plus 1 and so on. But it is doable for a small matrix like this, but what if I change this to 800 and 800? So it is not possible for that. So we have to make our constraint scalable to the changes, if any changes are made with the data structure. So what I will do, I will recall my previous lectures on system Verilog arrays and methods, and we do have the array reduction method, and one of the method is called sum, which will sum all the elements present inside an array. So using the for each loop, we are iterating through each of the rows. So we will simply just use the sum. So by using the sum method, we could just write something like this, that either it should be equals to 3 or the elements inside the row should be equals to 5. But here we will still have one critical problem. It is that the constraint will fail, and the reason is that uh, the here comes the role of the context determined expression. So uh, each elements in the array are of bit data type, and a bit is just a single bit. So the return type of the sum method will also be as bit. It will also be of bit data type. So for each of the constraint, we will get a sum of 1, which will result in direct conflict with the conditions present inside the constraint. Because if you will do the sum, let's say inside one of the row, we have something like this: that first element is 1, then the second element is 0, then 1, then 0, then 1, then 0, then 1, then 0. So there are 8 elements. So technically, using the sum method, we should get something like this: 4. Or let's say we want to satisfy our constraint, we could just remove 1, 1, and we will get something like this: 3. But the problem lies with the context determination. Since the radix here is a bit data type and each elements are of bit data type, what will happen? The result will get truncated to a single bit. And for 3, if you will just convert the 3 to binary, it is 0, 1, 1, and it will get truncated to the LSB, which will result in getting 1. And this will directly get conflicted with this constraint and also with this constraint. So to solve that, I also introduced the with clause on my previous lectures. So you just have to use the with clause, and inside the with clause you will use the round brackets, and then you will do the static casting of the item. The items are the elements of the arrays. So you just have to do the static casting, and you should do it for the item. So what it will do? Firstly, the with clause should come after the uh, condition. So here it should be something like this. So what it will do? It will just sum all the elements present inside the array, and this time because we are doing the static casting of all the elements, those are items, using the with clause, it will not truncate the entire result into a single bit value. Instead, it will return the value in int data type. So we will not have any constraint issues or any constraint failures. So to make this even more robust, what I will do, I will just write a single with clause, and I will do the static casting, and I will cast the result with int data type, and then I will use inside keyword, and we will have two values. The first value is 3 and the second value is 5. So what I am doing here, I'm just adding all the elements present inside a single row, and then I am doing the static cast of the result so that it will not get truncated to a single bit. And then I'm putting it, I'm using the inside keyword to constrain it to be either 3 or 5. So by this way, the constraint should surely work. So after we are done with our main constraint, let's write a simple post randomized function in which we will display each rows of A. So I will iterate through each of the rows of A and I will just display them using %p. So we are done with our class. So let's go ahead and create a module. So I will declare the handle of our class. Let's call it C1. Now let's start our initial begin block. And let's assign the object to our handle. And right after this, I will randomize the class, the object, and I will do that inside the immediate assertion. Else it will trigger an error. So let's go ahead and open the QuestaSim. And let's compile the code to check whether I have made any typos. Okay, I do have an error and it is at line number 25. All right. Oh, I don't know why did I write post randomize here. It should be randomized. Oh, it might be the I might have used tabbed in VS Code, which have written post randomized, so it should be randomized. So now it should work. So let's start the simulation. Okay, what we have right here. So these are all the rows of our A element, and we have to count that how much, what is the what are the numbers of ones right here. So the total sum as per our constraint should either be 3 or 5. So let's check it. So in the first one it is 5, yeah, correct. In the second one also it is 5. In the third one also 5, and in the fourth one it is 3. There are total number of three ones. And in this one we have 3 ones, so it is 3. And in this one there are total number of 5 ones, so it is 5. Here we have total number of 3 ones, and here we have total number of 3 ones. So it does succeed. Our constraint passed, and we are getting the desired values for the data element A. So what would have happened if you did not, let's comment this out and let's check it, how important it is. So I will just use equated to 3, and as I have discussed right here, that since the result will get truncated to a single bit, there will be a constraint mismatch, and the entire simulation will terminate. So I will just save the code and I will just compile it. Let's start the simulation. And let's run the simulation. So you could see it right here that randomization failed due to conflicts between the following constraint, and it is showing you the entire graph that what is happening, and it is showing you the entire flow that the the sum of row, each elements of the row are not equals to 3, and same goes for everyone. So the randomization is failing right here, and our dollar display system task message is also getting printed right here. So that was the importance of using with clause when all the elements are of single bit data type, because at the end the result will be of the same radix of which the data elements is. So data element is of bit data type, so the result will be of bit data type. So you have to keep that in your mind. So I will put a link of this code in the description box below, so be sure to check it out. And that's all for this video. Thank you so much.